Explain Schrodinger's cat with the honesty box. So the idea with Schrodinger's cat is if you have this...
I have a cat here for you, by the way.
There's a cat, right? So I get this cat and I put it in a box, and I have a radioactive nucleus in the box, and if it decays, the nice way to say it is it releases a sleeping potion, but in its original form it releases poison. And so if it decays, it releases some poison which kills the cat or puts it to sleep, and it could wake up again at some point depending on how sensitive you are. So it's either dead or it's not, depending on whether this thing decays or not. There's a probabilistic prediction for whether this thing is decayed or not. In just pure quantum mechanics, the nucleus is what's called in a linear superposition of states. So it's sort of some probability of being decayed plus some probability of being not decayed, and that's how you describe the nucleus. So that would suggest that's how you describe the cat. So the question is the correct description of this cat both alive and dead with some different probabilities that can change over time? But is that the correct description? And then you open it, of course, you see that it's one or the other. And so the question is that nonsense? Or the modern interpretation, especially the many worlds interpretation, would be that there's a universe where this thing is decayed and the cat's in, and I open this up and I see that it's alive or dead. So there's a universe in which I see it alive and a universe in which I see it dead, and the whole thing is just a big ensemble of probabilities called a wave function. So it was initially a kind of thing to say, well, this is a bit weird. It's got weird implications, quantum mechanics, and ultimately it does have weird implications. And so that's it.